So topic 6 is titled Solving Quadratics by Completing the Square Part 1. It's Part 1 because topic 7 is Part 2, which just ups the difficulty a little bit. But the method here is completing the square, okay? So we've already learned graphing, factoring, and square roots. Completing the square is the fourth method that we're going to learn. Before we get into that, though, I'm going to review just a couple skills that you already know how to do, but you need in order to figure out completing the square. So the first thing is just factoring perfect square trinomials. Okay, so looking at what I have written here, 4x squared plus 12x plus 9. Let's first check to make sure that this is a perfect square trinomial. Well, square root of 4x is 2x, square root of 9 is 3. We put those two things together by multiplying, and we get 6x, and then we double it, and we do get 12x. So yes, this is a perfect square trinomial. Now, the way we factor it, we remember this is the long problem, so it's going to create the short answer that looks like this. So I take the square root of my first term, 2x, square root of my last term, 3, and then the sign in the middle comes from the sign on b, so this will be a plus. So 4x squared plus 12x plus 9 factored is 2x plus 3 all squared. Okay? Just a quick little recap on factoring perfect square trinomials. The other skill that I want to make sure we review is just solving with square roots, which is what we did in topic 5. So this should still be pretty fresh on your mind. So solving with square roots. So this problem right here, x plus 6 all squared equals 25. We're going to start by taking the square root of both sides so that we get x plus 6 equals positive 5 and x plus 6 equals negative 5. So then we just solve each side. Minus 6 everywhere. So x equals negative 1. And x equals negative 11. Okay, so again, those are two skills you should already know how to do, but we're going to put them together to help us solve by completing the square. So, numbers 1, 2, and 3. It says the following quadratics have been rewritten using perfect square trinomials, solved by using the square root method. So on number 1, the way they've gone from the first step to the next step is just by taking the left-hand side and factoring it as a perfect square trinomial. So we know the square root of x squared is x. We know the square root of 25 is 5. So they factored it. X plus 5 squared equals 36. So we know that the first equation and the second equation are the same. However, written as the second equation, we can solve it by taking the square root of both sides. So x plus 5 equals 6, and x plus 5 equals negative 6, just like we were just doing. I'm going to subtract 5 from both sides on each equation, so x equals 1 and x equals negative 11. Okay? Number 2, same thing. I thought I had that same problem twice. It's just a coincidence. So number 2, same thing. They have factored the perfect square trinomial here to get 4x minus 1 squared equals 49. So again, we're going to take the square root of both sides. So we get 4x minus 1 equals 7, and 4x minus 1 equals negative 7. We solve so that x equals 2 as our first answer. And x equals negative 3/2 as our second answer. Number 3, same thing. We have a perfect square trinomial that has been factored into x plus 7 squared. Now we're going to take the square root of both sides. What's slightly different about this one is that the square root of 13 isn't going to be a whole number. 13 is not a perfect square. So the square root of it is just plus or minus the square root of 13, right? We don't actually put a number there. We could approximate it to a decimal, but we don't really want to do that. So now I'm going to subtract 7 from both sides so that x equals negative 7 plus or minus the square root of 13. Okay, now that's kind of weird. We haven't really seen answers written that way yet. So let me break that down for you just a little bit. If I actually move it even further down, if I were to split it apart, x plus 7 equals the positive square root of 13, and x plus 7 equals the negative square root of 13. In either case, I'm going to subtract 7, right? And I could write it as the square root of 13 first, but we know that the square root of 13 minus 7 is the same as negative 7 plus the square root of 13. These two things are the same. So typically you see it how I wrote it the first time with the square root of 13 at the end and that negative 7 in the front. And once we do topic 8, that'll become second nature and it won't be a big deal once you learn the quadratic formula. So don't stress over that too much. Okay, so hopefully that was not a big deal because that's really just review from topic 5. But now we need to do that step ourselves. So it says solve the following by using the square root method. So on number 4, we need to take this first portion of our problem and create the factored form. So I know that x squared is a perfect square trinomial. I know that x squared is a perfect square, 16 is a perfect square, and this middle term is the double of those two square roots put together. So my factored form would be x plus 4 all squared equals 64. Now I can work backwards by taking the square root of each side so that x plus 4 equals negative 8, x plus 4 equals positive 8. So x equals negative 12, x equals 4. Okay, so all that's been added here is the step where you have to do the factoring to create the factored form. So this perfect square trinomial, again, square root of this is 2x, square root of this is 9. Makes sense that if you put those two together and double it, you get 36. So our factored form would be 2x minus 9, all squared is 100. So now we take the square root of both sides. So 2x minus 9 equals 10, and 2x minus 9 equals negative 10. Then we just work backwards. So x equals 19 halves, and x equals negative 1 half. I believe I did that right. Yep. Number 6, feel free to pause if you feel like you've got this and you'd like to try this last one on your own. So I'm going to factor this, and we get 3x plus 1 all squared equals 20. So I'm going to take the square root of both sides. So 3x plus 1 equals, now here, because again 20 is not a perfect square, I'm going to write plus or minus, and I'm actually going to break 20 apart into 4 times 5, which becomes 2 root 5. Now I subtract 1, so 3x equals negative 1 plus or minus 2 root 5. And I divide both sides by 3. Oops. So that creates x equals negative 1 plus or minus, 2 root 5 all over 3. Again, if this answer format that we just wrote is kind of tripping you out, please don't feel like you don't understand today's lesson. We'll get used to that as we deal with the quadratic formula, so don't stress over that. Okay, so it says completing the square. That's what this method is called, and we haven't even really done it yet. Completing the square creates a perfect square trinomial within an equation, which allows us to solve the quadratic by using square roots as we did above. So, just to recap, the method is actually creating a perfect square trinomial. So look at number 7. We're going to walk through this following the steps on the left-hand side, which are the steps for completing the square. So, it says first step, move C to the other side. So I'm going to just rewrite my problem first. Because what I have right now is not a perfect square trinomial, these 3 things do not create a perfect square trinomial. So I'm going to go ahead and move 16 to the other side. So I've got x squared plus 6x equals 16. I intentionally left a blank here because I'm going to put something there here in just a second. Okay, but that was step 1, move C to the other side. Step 2, it says find the value that completes the square and add it to both sides. In other words, we want to know what number can I put in this blank that I drew that will make this left-hand side a perfect square trinomial? Well, if the square root of this is x, square root of this is something, but when I put them together and then double it, I get 6x. I just want to work backwards through that process. So if 6 has been doubled, that means before that it was 3x. And if this is what contributes the x, then this has to be the 3. Well, then I think, okay, well, what number would go up here that would create a 3 when I take the square root? Well, it'd have to be a 9. But because this is an equation, if I add a 9 here, I have to add a 9 over here as well to keep the equation balanced. Okay? So now let me just rewrite what I have. Now I have x squared plus 6x plus 9 equals 25. Now I'm ready to actually solve it just like I did on numbers 4, 5, 6. Okay, so now I'm going to take this, rewrite it as x plus 3 squared. Now I'm ready to take the square root of both sides. So x plus 3 equals 5, and x plus 3 equals negative 5. So x has to equal 2, because I'm subtracting 3, and x has to equal negative 8. And those are my two answers. I know some of you are probably like, what just happened? Remember that the beauty of it being a video is that you can rewatch everything I just did, but I'm also about to do a whole bunch of problems with you, right? So if at any point you feel like you need to watch it again, go ahead and rewind, but also just hang in there with me because I'm going to do a couple more problems with you. So the instructions here just say find the missing term that would complete the square. So that's all we're doing is we're thinking about what number would go there. Well, the square root of x squared is x. Square root of this is we don't know. But I know that when I put them together and I double it, I'm supposed to get 16. Well, that means before 16 was doubled, it had to be an 8x. And if this x is already there, then this has to be the 8. Well, what square rooted is an 8? 64. Over here, same thing. Square root of this was an x. Square root of this is we don't know. But we know put together, they have to be 4x doubled. So it means it has to be 2x. Which means this has to be a 2. So this has to be a 4. Now, the way to come up with this number systematically would be this right here. You take the b and divide it by 2, which makes sense, right? You take this number and divide it by 2, because that's how you get this. And then you square it to get back up to that original c value, okay? So that's why it's written like this, b over 2 squared. Now, that's how you get the c that you add on. Number 10 is kind of a special problem. That's why it's got this asterisk, just to show, as a reminder, what would the middle term have to be. So if square root of this is x, square root of this is 5. To get the middle term, you put these together and double, so it'd be a 10. Okay? But if you're looking for c, you take the b value, divide it in half, and square it.